A sound wave resonates in a pipe that is open at both ends. That's what this is showing you, and that's why they call it an open tube. The length of the pipe is 1.6 meter. What harmonic is shown in the pipe? What is the wavelength of the sound? What is the fundamental frequency? And then what is the third harmonic? For an open tube, the harmonic is the number of half wavelengths. And there's another name for that. We just call them loops that resonate in the tube. So let's just sketch a picture here. Hopefully you can see how that's one wavelength. So what we're considering a loop is this piece right here. That's a loop, or 1/2 wavelength. So let's count the loops. Here's 1, 2, 3, 4. Then we have half a loop here at this end and half a loop here at this end. So the total is 5 loops, which makes this the fifth harmonic. What is the wavelength of the sound? We have an equation here. The wavelength is 2 times the length of the open tube divided by n, the number of harmonics. Does that look familiar? Perhaps you remember from the wave section when we had a vibrating string, had a pulley there, and then we had a mass. We had the same exact equation for the wavelength. So the length of this tube is 1.6 meters. We're looking at the fifth harmonic. We got that from part A. So the wavelength is 0.64 meters. What is the fundamental frequency? The fundamental frequency is the frequency of the wave when only one half wavelength is formed in the tube. And in that case, n is equal to 1. So let's look. This is what it would be. So if we were to count here, we'd have 1/2 loop there, and then another loop here, half a loop. So 1/2 plus 1/2 is 1 loop. So we have F is NV over 2L. We have n is equal to 1, which is also the number of loops. So if we have 1 times the speed of sound, again, if you do this a lot, you'll kind of memorize this, but if not, that should be on your table of constants. Here's the length of our open tube, and the frequency, the fundamental frequency, would be 106 Hertz. What is the third harmonic? The third harmonic is the frequency of the wave when 3 half wavelengths are formed in the tube. So that means n is equal to 3, so we should see 3 loops. So here's our curves. Here's 1. Here's 1, here's a half, here's another half, so that checks out. So the third harmonic frequency, f sub 3, will be n times f1, n is equal to 3. We found the fundamental frequency on the previous slide, so the third harmonic is 3 times that, or 318 Hertz.